Hey guys, today we're going to solve LeetCode number 785, is graph bipartite. So we're given an undirected graph and we need to return true if and only if it is bipartite. So the graph is given to us in the following form. Graph of I is the list of indexes j for which there exists an edge between I and j. Okay, so we're going to do this with a for loop. First of all, we're going to store in an array the current color of every node in the graph. So right now all of the colors are undefined here. And now we're going to use a for loop to check for conflicts in our graph. So here in this loop, we go through all of the nodes in our graph. And if we, in this for loop, we're going to return false if we ever find a conflict. So if we never find a conflict, then we can return true here. Okay, so how do we check for conflicts in our graph coloring? Well, first of all, we check if the current node color is undefined. And if it is, we can assign any arbitrary color to it. So if the current color of the current node that I'm visiting is undefined, then assign to it like black or white, which could be represented with 0 or 1. So here I chose 0, but you can go with 1. It doesn't make any difference here. Okay, so now that we assigned a color to the current node, we can start checking for conflicts. So this is going to be a function, a recursive function that does a depth-first traversal of the graph and checks for conflicts. And if it finds a conflict, this function is going to return false. And it returns true if there are no conflicts. So if there are conflicts, then we want to return false straight away. Okay, so now all there is to it is to implement the depth-first search function. That's going to be a recursive function with a very similar structure to this up here. The only difference is that because we have a starting node, now we can't just set the colors arbitrarily, but we need to assign the opposite color of the current node. And obviously we also have to actually do the checking of the possible conflicts. Okay, so we're going to loop through all of the neighbors of the current node, and we're going to do a very similar thing to here, where at the end, if we don't find any conflict, we return true. And here we have to check for conflicts now. So first of all, we do the same thing that we do here. So we check if the current color of this neighboring node is undefined. And if it is, fortunately here we can't just assign any random color. We need to assign the opposite color of the current node, which is I. And to do that, we can do 1 minus the color of I. Because if color of I is 0, this would result in 1, which is the opposite of 0. And if the color of I is 1, this would result in 0, which is the opposite of 1. So yeah, this gives us the opposite color. And now that we've assigned one color, then we're going to have to start a depth-first traversal of the graph from this new neighbor as well. And yeah, it's the same thing as here. You can see it's literally the same structure. You see, if we find a conflict, return false. If we don't find any conflict, keep moving forward in the iterations. Okay, and after having done this check, we can now check if there is a conflict. So we check if the color of the neighbor is equal to the color of the current node. And if they are equal, we have found a conflict, so we're going to have to return false. But if we never end up in this line, so this is the crucial line. If we never end up in this line, it means that we are never having this condition. We're never returning false here, meaning that we're never returning false here, meaning that we're going to end up here in the return true. So we return true if this condition is never met, if there is never a neighbor node that has the same color as the current node. Okay, so I'm going to submit the code to show you that it works. And it does. So that's it for now. Thank you and bye.